Fantastic. So it's my pleasure to introduce Gans Srinivasa, who is with Omics Data Automation, and will be speaking to us about multidimensional data aggregation and analysis for healthcare. So, welcome.
Thank you. Thank you for taking the time to listen to this, and thanks to Michael for allowing me to sponsoring this. So Omics Data Automation, we basically focus on multiple modalities of data aggregation, and then how do you use it for medical purposes, essentially, in the clinic or in the hospital. And I'm going to take how we are doing it in the cancer world. That's in a nutshell. So the medical data industry extracting value is a big problem, and we have multiple silos of data. So we have heard a lot of talk about taking electronic health data, but the question is, when a cancer patient comes in, they have your radiology data, they have pathology data, they have genomics data. If it all adds up, essentially, for the same patient, it's going to be massive. And if you can look at the chart, it dwarfs YouTube data. If every other patient is at least sequenced, even panels, that's what it's going to be. So the key question is, how is the medical industry going to keep up? This is huge. This is the big data, what we are talking about. And the question is, they are in desperate silos, and they are expanding. So the question is, let's take a simple example. 15 years back, when your cancer patient goes in, your biopsy, your blood work, and you decide the protocol. Now you have multiple biopsies, multiple panels. The future is daunting. So the question is, how are you going to cope up with it? What are the mechanisms? Then the problem becomes much more acute. If you really look at it, the doctor does not want to depend on a machine. We have heard from AME, American Medical Association, a bunch of doctors this morning, yesterday, that they are not going to trust just deep learning as it is. So there is a question here, this is the reason. We have the human cognitive capacity, the doctor wants to causally think, and there is a relationship between the patient and the doctor, and the machine spits out, we don't know whether the noise, whether they trust it. So this is the biggest issue. How are we going to solve it? Is the big data, the data science is really equipped to do? That's what we are focused on. And the simple question is, if you want to do that, first you need to aggregate the multiple types of data, just not electronic health record and claims data. We need to mingle that with imaging. We need to mingle that with omics data, and essentially have an ability to store data at scale and analyze at scale. That means we are talking about a scalable compute. So there are two technologies, we have to figure it out. And simply giving it in a cloud is not a cost-effective manner. So we need to have a framework. So that's what we focus on Omics Data Automation. The red box is the framework. It's basically a software framework. We made it and selling it. And then the question is scalable interface. Each one have a different interface. What you see is what you think is underneath it. But no, it has to have the entire framework, and you can be selective. So the data scientist wants to do population analysis, whereas the clinicians don't have much time. They have to focus on the patient. And they can't just simply wait for the AI to tell, yeah, this is it. They want a causal inferencing, because the cognitive ability of 10 variables, can you contextualize it? And that's what DARPA is spending a lot of money. I gave you a talk prior, so you can check that out. So that's what we do in the business in Omics Data Automation. And how we do that? So the key is, you have to basically smash all these data, various types of data, aggregate and harmonize, and annotation is very key for cancer. If you don't know how to annotate it, and you are not helping the physician, it's too much data there. That's the key. And then you can talk about deep learning or causal model, that I'm going to leave it separately, but that's where the basic operation is. Essentially, the scalable compute and the interfaces. This is the technology. We have got a bunch of patents that's going on onto this, the framework. And the products we are making is essentially, you can have an insight, which is a causal learning insight, causality based. And that means you can have a mechanistic model on that. That is the third wave of AI, which we call it. Or we can take about the basic data of your patient that can be used in your tumor board. We have currently hospitals trying out the tumor board software, which is My Patient. And there are major hospital chains who are using the My Cohort basically for doing population-weight analysis and seeing the population effect on this. So these are the scalable interfaces that we are selling it out. So this is another product on top of our framework. So let me give you a specific example, because I don't want to talk about many of my customers because they are all like competing with each other, but BAMF is a different case. So what we do for them is, they are a company which is focused on radiotheranostics, basically. I don't know how many of you have heard of them, but they are basically nuclear medicine they are practicing. And they have electronic health record or lab data, and they are particularly relational database, which is a well-known solved problem. The pathology, radiology is imaging, and genomics, proteomics, and transcriptomics is another type of data. So we built a system on the framework. Something looks like this. Basically, it has multiple components. One is the deep learning model, which tells you the PSMA level for a prostate. That's using image analysis. And then we have basically a conceptual model of a causality based, so that which kind of operations you can choose for that treatment for the patient, and essentially genomic analysis. All are integrated into that. Yes. So the key question is, we can answer many of the advanced analytics based on these things, whether what kind of treatment you do, actual treatment, or we can ask the counterfactual questions, because whether this person has to have a surgery or not, whether we can avoid a surgery, all kinds of analysis is very critical because they affect the cost and they affect the patient outcome. So that's what we focus on in terms of advanced analytics. That's basically pushing the AI boundary beyond deep learning. And these are our products in a nutshell. A framework product for major hospital chains or pharma, and then these are the targeted products for clinical physicians. So that's in a nutshell. Questions? Wow, I don't have any questions. I have more questions on the technical side.
Well, I guess you covered everything. Thanks so much.
Thank you.
All right.